Hello students, now today we are going to start the topic that is the AC fundamental and the circuit. The AC fundamental and the circuit. The alternating voltage whose continuously varies in magnitude and periodically reverses in polarity. Okay, it is the nothing but it is a alternating voltage. In this, if we are considering the rotor, it generates a loop. That particular loop is rotating the magnetic field to produce the induced voltage with alternating polarity. Okay, when you are using this particular formation, you have the generation of the particular voltage. Now, when you are generating the alternating voltage, generation of alternating voltage, generation of alternating voltage. Okay, students. In this generation of alternating voltage, it can be produced by using the rotary generator. The conductor loop or the coil rotates through the particular magnetic field. The lines of the magnetic flux are cut by the loop or a coil. Okay, when we are using that particular formation, when one particular angle of the rotation, that is a theta, it varies from 180 degree to one particular certain 360 degree. The loop cuts the magnetic field in an opposite direction, hence the induced voltage is negative. Okay, now consider one circular path. This is one particular circular path. If we cut this circular path into two half portions, okay, the x-axis and the y-axis, what you are going to observe in this particular form, you have the four different coordinates. Okay, these are the four different parts which is being cut by the two axes, that is x and y. Here you have the value that is 0. This is the 90 degree value, it is 180 degree value, it is 270 degree value, and again it will be 360 degree value. Means a one complete path for a one circle it requires 360 degree. So in this particular format you have the angle which is going to be start from this. We are going to anti-clockwise. We are not going clockwise, we are going to anti-clockwise. Okay, so in this particular format, when you are using this form, you have generated this alternating value. Suppose it is the x-axis, it is the y-axis. In the axis x, we are going to measure the time, and in the y-axis, we are going to measure the voltage. Okay, now from 0 to 180 degree and from 180 degree to 360 degree, if we make the wave in such a way that it will produce the alternating value of 360 degree, then the wave will look like this. Okay, this is the wave which is being looked by you. Okay, this is the wave. Now starting from 0 degree, if we cut this particular into the 1/4 part, then half part, then 3/4 part, and then 360, means a total full path. Means from 0 to 360 degree, if the value of this particular sign, it is nothing but to be called as a one cycle. It is called as a one cycle. Okay students, this one cycle indicates that from 0 to 360, again you may say that as we are going to calculate the value for the t, for a one complete cycle it requires the t cycle also. Okay students, 0 to this part means quarter, 1/4. It is indicated with a 90 degree. 0 to this half part, it is indicated with a 180 degree. 0 to 3/4 part, it is indicated with a 270 degree. Okay, means of four types of the angle which satisfy this particular value. When one complete cycle has been given to you, one t cycle has been given to you, it means that in the y-axis we are now going to measure the value that is at voltage. So here, suppose the upper side means you may say that the half portion for the positive, it is indicated with a plus Vm, and the below portion, that is a negative sign, it is indicated with a minus Vm. Okay, and if we are able to combine this positive and the negative, you will be saying that it will give you the value that is of VPP. Okay, from this point to this point, if you are going to measure, and you will be getting the value of a voltage, that voltage is nothing but the VPP, and VPP is nothing but, it is called as a peak to peak voltage. Okay, this peak to peak voltage, if you are going to find out this particular small v, then small v is equal to capital Vm into sine omega t, or you may write down only the theta. Okay, so it is one of the most important formula which is related to this particular sine wave. Now, when you have used this particular sine wave, you have, suppose the A value has been get considered like this. Suppose it is a B value, it is C value, and it is D value. Means from A to B, B to C, and C to D, and from again D to A. We will give here the name, that is starting from 0 means A, up to 90 degree we will give here B. From B to C, it is this one. From C to D, it is this value. Okay, or you may write down D just below the 270 degree, and from D to rest again it is D. Okay, so this will give you the full complete 360 degree value. When you have that particular Vm, this Vm is nothing but it is the maximum voltage. Vm is nothing but it is called as a maximum voltage. Vm, maximum voltage. Okay, Vm is the maximum voltage. When this particular maximum voltage, and you have the theta, you have the theta, this one theta, this theta is nothing but it is the angle. Theta is the angle. The angular measures or medium measures can be used for the alternating quantity. In an angular measure, the complete circle includes a 360 degree. Therefore, one cycle corresponds to at a 360 degree. When you are using this particular form, you have got from here to here half, and from half to next half, you are getting the next cycle, that is a negative cycle. Positive to negative, and from negative to positive. Now, for a 1/2 cycle, how much degree you are going to be found out? For a quarter cycle, how much degree? For a 3/4 cycle, how much degree? And for a one complete cycle, how much degree you are being found out, that we will see. Okay, now from this 0 to this 90 degree means it is quarter, 1/4 cycle, you will get the 90 degree. From 0 to C means it is a half cycle, you are getting 180 degree. From this 0 to this particular D, it is a 3/4 cycle. 3/4 cycle, you are getting 270 degree. And from 0 to again A, you are getting the one complete cycle. Okay, one cycle will give you the 360 degree value. So these are the different cycles, you are getting the different angles. But if in a radian, if in the radian, it measures the specific unit angle, and in that particular unit angle it is nothing but it is called as a radian, and that radian is used, the one radian, it is 57.3 degree. One radian value, one radian value, it is 57.3 degree. Okay, now in this particular radian, if you are able to calculate this one, means this value, this value, and this value, and this value in a radian. Okay, 0 to 90 degree, 0 to 90 degree, I told you it is a one particular quarter cycle. This quarter cycle, it is nothing but it is indicated by pi by 2 in a radian. Okay students, half cycle, this half cycle in a radian, it is indicated with a pi radian. Then 3/4 cycle, that is nothing but it is a 270 degree. This 270 degree, it is indicated with a 3 pi by 2 radian. 3 pi by 2 radian. Okay, and the one complete cycle, that is a 360 degree. In a degree it is measured with a 360 degree, but in the radian you will be saying that it is a 2 pi radian. Okay students, so you may differentiate here also the degree and the radian. Okay, the sine wave. In that figure, whatever the figure we have studied up till now, the wave which we have drawn here, that was a 360 degree wave. In that 360 degree wave, as I told you, if we are going to measure from this part to this part, you will be seeing that it is a BPP. Here the positive, that is a Vm, minus Vm, it is being indicated. In the x-axis we are going to calculate the time period, and in the y-axis we are going to calculate the voltage. Okay, that voltage for the first positive cycle plus Vm, and for the first negative cycle it is minus Vm. We have the small voltage, that is small v is equal to capital V and the sine theta. This Vm, I told you, it is nothing but it is a maximum voltage, and the theta, it is nothing but it is the angle. Okay, now this sine wave, we have the different parts. The amount of the induced voltage is proportional to the sine of the angle of the rotation in a circular motion. Okay, since the voltage waveform is called as a sine wave or a sinusoidal wave. The characteristics of the particular sine wave is been indicated by the AC waveform. The cycle includes a 90 degree, that is 270 degree, 90 and a 270 degree. It includes a 360 degree. When the characteristics has been occurred, first the cycle includes a 360 degree, that is a 2 pi radian. The maximum value at a 90 degree and a 270 degree. This is the maximum value for the positive cycle. This is the maximum value for the negative cycle, and that's why 90 degree and a 270 degree, they have indicated as a maximum value. At a 0 degree, this 0 degree, this is the 180 degree, the value will be always 0. It is indicated with this 0. Okay, then the polarity reverses each half cycle. This is the half cycle. This is the half cycle. The 0 to 180 degree. As soon as the 180 degree get completed, the next cycle which is arise, that is from 180 degree to 360 degree. And that's why they have told that the polarity reverses each half cycle. Next, if you are going to draw, then you will be getting this half cycle. Next, you are getting this one half cycle. So for each half cycle, the polarity is going to be changed. That is positive, negative, positive, negative, positive, negative. This is the positive, negative, positive, and the negative. Whenever there is cycle completion occur, the positive and negative cycle will be get formed. Okay. So here the value changes the fastest when the waveform crosses the zero axis, and the value changes slowest when the waveform crosses that particular form. Okay, so here in the maximum value, the different voltages, we have to study the voltage and the current value for the sine wave. As previously I told you, the voltage value, that is for the positive half cycle, it is considered as a plus Vm, and for the negative half cycle, it is considered as a minus Vm. So when this particular, the instantaneous value, the value of the alternating quantity at a non-instant time, it is called as an instantaneous value. Okay students, the value for that particular instantaneous quantity, that instantaneous quantity is nothing but it is either the current or the voltage, and it is known as the instant time, it is called as an instantaneous value. Since when the alternating quantity has a many instantaneous value through the cycle, it is convenient to define the specific magnitude for comparing the one wave to the another. The following specific value can be used for either the current or the voltage. Which are that particular values? You are getting the value first, it is a peak value. Okay. In the cycle, we have studied for one complete cycle, you have this positive means a plus Vm value, and here you are getting the minus Vm value. If you are able to combine that positive and negative voltages, then you will be getting the value that is a VPP. That VPP is nothing but it is a peak to peak voltage. Now, what is that particular peak voltage? The maximum value Vm or the current. If we are going to consider the current for a maximum, then it is indicated with the Im for the positive, and if it is negative, then it will be indicated by the minus Vm. Okay. The peak value applied to each of the other positive and negative peak. This is nothing but it is called as a VPP. This VPP is formed, it is twice into peak value. VPP is equal to twice Vm. You are getting VPP is equal to twice Vm. How this Vm is occurred? This plus Vm minus in bracket minus Vm, you will be getting the Vm plus Vm, that is twice Vm. Since you may say that the peak value, that is the peak to peak voltage, that is the VPP is equal to twice Vm. Okay. Then the average value, it is a arithmetic average for all the values in a sine wave for the half cycle. For the half cycle, the value has been given to you. The average value is specified only for the half cycle because over a full cycle the average value is always 0. One complete cycle, here from here to here, always the value will be again 0, and then again the positive value and again the negative value will be occurred, and as soon as the 360 degree completes, again the value will be 0, and that's why it is nothing but it is a average value, and it is indicated with this formula, that is 0.637 into the peak value. Whatever the peak value has been assigned to this particular wave, it is indicated with a 0.637 multiplied by peak value. Then comes a root mean square. That root mean square is nothing but it is a RMS value. It is the RMS value. This RMS value for that particular sine wave or the voltage is the current at a 45 degree, okay, which is a 70.7%. It is a 70.7% of the peak value. It is called as a root mean square or the effective value. The RMS value, it is given by 0.707 multiplied by peak value, or you may say that Vrms is equal to 0.707 Vm and Irms is equal to 0.707 Im. If it is in a current, then this value you have to keep in your mind. If it is related with the voltage, then this is the value which you have to keep in your mind. Okay students, the RMS value of that particular alternating sine wave, it corresponds to the same amount of the direct current or the voltage in a heating power. Okay students, then the power, it is indicated with a P is equal to I square into R. It is a standard formula. This P is equal to I square and P is equal to I square into R, that is nothing but it is equal to V square by R. You may say this one is the value. So when you are indicating this one particular value, it indicates otherwise all the sine wave, the AC measurement are in the RMS value. The main supply, that is a 230 volt, the RMS, that is a 230 volt you are getting. The form factor, the form factor which you are getting in this particular wave, that is the RMS value divided by average value, you are getting 1.11. Here it is written. In the form factor, RMS value by average value, it is 1.11. Okay. Related with this particular wave, you have to keep some definitions in your mind. The important definition, that is a frequency. This one particular wave, it indicates the frequency. The frequency is nothing but the number of the cycle per second. It is called as a frequency. The unit for the frequency, it is hertz. It is indicated with the hertz, or you may say that it is a cycle per second. In this particular hertz or a cycle per second, the 1 kilohertz, 1 kilohertz, that is 1 kh and z, it is indicated with a 10 to the power 3 hertz. If it is 1 megahertz, then it is 10 to the power 6 hertz. If it is 1 gigahertz, then it is 10 to the power 9 hertz. And if it is a 1 terahertz, then it is 10 to the power 12 hertz. Okay, students. So here the gigahertz 10 to the power 9, terahertz 10 to the power 12 hertz. Okay. In India, as you know that in our India there is a 230 volt, but the frequency in our India, it is a 50 hertz. But as soon as you go to the outside, means in a foreign country, in a USA, the frequency of the power supply is going to be changed. Okay. Here in our India, 230 volt is required for the AC supply, and the frequency is required in our India, it is a 50. But in the USA, the voltage required, that is a 110 volt, but the frequency is high. Due to that particular frequency, what is the frequency? It is a 60 hertz. So in a USA, the frequency power supply is a 60 hertz. Okay. Then comes a period, that is a time, that is a period T. The amount of the time for a one cycle, it is called as a period. The amount for a time for a one cycle, this is the one cycle. So this one cycle, it is the period or the periodic time. It is indicated in a SI unit, that is a second. Here the T has been defined. If you have the frequency, okay, frequency I told you, but as soon as the time period comes, it is related with the frequency, and that's why T is equal to 1 upon F. You are getting. Okay, this frequency and the time, it is related. The 1 millisecond, it is 10 raised to power minus 3 second. 1 microsecond, it is indicated 10 raised to power minus 6 second. 1 nanosecond, it is indicated with a 10 raised to power minus 9 second. 1 picosecond, it is indicated with a 10 raised to power minus 12 second. Okay, so these are the few definitions which you have to keep in your mind for your examination point of view. Okay, then the wavelength, it is indicated with this lambda, the distance traveled by the wave in a one cycle. The distance traveled by the wave in a one cycle is called as a wavelength, and its SI unit is in a meter. The lambda, it is indicated, the wavelength, this symbol, the wavelength, it is indicated with the velocity by frequency. Okay, the electromagnetic wave, the velocity of the air or the vacuum, it is 3 into 10 raised to power 8 meter per second, which is nothing but it is the speed of a light. Then comes the phase angle. The phase angle is an idea of a time relation between the two alternating quantity like a voltage or the current. Okay, in a sine wave, the instantaneous value of the voltage or the current, it depends upon the angle of the rotation of a rotating loop. This angle is nothing but it is called as a phase angle, and that phase angle in this wave, as I told you, V is equal to Vm sine of theta. It is nothing but it is a phase angle, that theta. In order to compare the phase angle between the two waves, if we are comparing the two waves, then the same frequency also there must be the sine wave variation, that is the amplitude can be the different of the two waves. Amplitude should be different. So suppose you have the two amplitude for the point at that particular reference. If the two sine wave being compared passes through that particular point to the same time, the two waveform is nothing but it is in a phase. both the waveform is going to pass from one this cycle. Okay, if you have this one particular cycle and then this cycle like this, then both the wave is going to be passed, that is, you may say that it is in a phase. If the wave do not passes through the reference point, suppose the wave does not pass from this point, it passes from this one particular point, then you may say that it is in a out of phase. Okay, if one cycle passes from the same cycle, previous cycle, then it is in a phase. But as soon as the one cycle doesn't pass from the previous cycle phase, then it is nothing but it is called as a out of phase. Okay, you have the different phasor diagram. Okay, this portion, suppose the waveform has been given to you and one single wave is going to pass from this particular cycle, means you may say that it is in a phase. Okay, this phasor means the value, this value and this value. The first cycle what we have considered, that is a VB, means this is the VB value. Okay, and which is the another cycle passing from that particular 0, 180 and 360 degree. Yes, it is a second, that is indicated with the VA, means here the VA has been occurred. So you may say that the angle is in a phase. This is nothing but it is called as a phasor diagram. In electrical, it is called as a phasor diagram. If the two wave passes through the reference point at a different point, passes, then you may say that one is leading and second is lagging. Okay, the passes to the reference point earlier is said to be lead and the other wave is said to be lag. Okay, students. Then here the different waves. Consider this figure. The two voltage waveform, that is a 90-degree out of phase as shown in this figure. Here, from here to this particular part, you have the 90-degree phase shift. Okay, out of phase, it is 90-degree. And the 90-degree angle, it is nothing but it is called as a quadrature phase. It is the quadrature phase. It is a quadrature phase. In this figure, the wave A is lagging by 90 degree and wave B is leading by 90 degree. Okay, if we are able to draw this one, you have the angle. Okay, what is the first wave? The wave number first, 1. The wave number 1, that is a VA, has been given to you. But the second number wave, but that particular second number wave, it is lagging by 90 degree. The leading by 90 degree. Means one is lagging, you may say that another is leading. So A is lagging by 90 degree or wave B is leading by 90 degree. Both of the statement you have to interchange. So VA and the VB, it is lagging or leading. The A is lagging, this A is back to the VB and VB is front. So you may say that VA is lagging and VB is leading by 90 degree. Okay, this is the phasor diagram for the waveform. Then if the two waves, if the waves, the first wave which is this one and this dotted indicate the second wave, means the two wave phases with an angle of 180 degree. From here to here the difference is 180 degree as shown. This means the opposite phase or the phases waveform are exactly out of phase. It is out of phase with a 180 degree and the equal value to the opposite phases cancels each other. So you may say that the phasor diagram for this one, what is the first value? It is a VB and what is the second value? It is a VA. So the total phase difference in this both the wave, it is 180 degree. Okay. Then comes the time factor in the frequency. This time factor in the frequency, only the definition you have to keep in your mind that the time factor is involved in both the frequencies and the phases. Firstly, it is very much important what is the phase and what is the frequency. The time factor, it involves both the frequency and the phases. As example, the frequency is of a 1 kilohertz and the time is of a 1 millisecond. Therefore, the clock frequency is a 1 millisecond. Unit is available. Even the smaller unit of the time can be measured by the higher frequency. The phase angle between the two waves of the same frequency indicates the specific difference in the time. The time for the phase angle theta can be calculated by t is equal to theta by 360 degree into 1 upon f. T is equal to theta by 360 degree multiplied by 1 by f. That f, this f, it is nothing but it is a frequency calculated in the hertz. This theta is nothing but it is a phase angle or a degree, and t is in a second. Okay, that t is nothing but it is a time. For example, they have given here theta 30 degree and f is equal to 50. This is one type of the problem which is given in the book. Then comes a non-sinusoidal AC waveform. In many of the electronic applications, along with the sine wave, other wave shapes are also important. Okay, which are the other waves? That waves is nothing but you will get the square wave, you will get the rectangular wave, you will get the ramp wave, you will get the one shape that is a sawtooth wave. Okay, so apart from the sine wave, we have to study these waves also. Okay, but in this particular formation, only the similarity they have given. This similarity between the sinusoidal and non-sinusoidal waveform. The cycle. First, the cycle is measured between the 2 points having the same amplitude and the varying in the same direction. The period in the time for one cycle. Second number point they have given. The third number point, both the cycle represents either the AC voltage. Okay, waveform represents the AC voltage. And the peak amplitude is measured. This peak amplitude measured from 0 axis to the maximum positive or the negative value. Then the difference has been given for the sinusoidal and the non-sinusoidal waveform. The peak to peak amplitude is specified for non-sinusoidal waveform because they can have unsymmetrical peaks. The angular measure is not used for the non-sinusoidal waveform. Therefore, the RMS value is not specified for a non-sinusoidal waveform. Third number, the phase angle do not apply to the non-sinusoidal waveform as an angular measure is not used for them as shown in the figure. Okay, which is that particular figure? It is this figure. Okay, as I told you, apart from the sine wave, this waves is very much important also. The sawtooth wave, the symmetrical square wave, then comes a asymmetrical rectangular wave. So these are all the particular waves which is nothing but it is called as a non-sinusoidal AC waveform. Okay, AC and the DC, the alternating current that is periodically reverses in the direction. Okay, the electrons which is flowing in the form of negative terminal to the voltage source through the circuit back to the positive terminal. The 50 Hz AC power line is common. It is a common example. Then the direct current has just one direction. It is unidirectional current and fixed polarity for the applied voltage and the characteristics for the DC circuit. The battery is a steady DC voltage source. This AC, you will be saying that it is the AC. Okay, and the DC, you will be saying that this is the DC. Okay, students. So there is a comparison between the AC and the DC. This comparison is very much important because without this comparison, you are not able to identify how the waves have been occurred. Okay, the AC voltage and the DC. In the AC, the polarity changes in a 2-half cycle. In a DC, the polarity is fixed. AC, the magnitude changes continuously. Here, the magnitude can steady or it may change. In an AC, can be stepped up or stepped down using the transformer. It cannot be stepped up or stepped down by using the transformer. It can be used as a single input and the output for the amplifier. This electrode voltage for the amplifiers are DC, easier to amplify and easier to measure. In an AC, the amplification is very much easier, but in the DC, it measures the value very easily. Okay, the different waveforms which is indicated is like this. So these are the two waveforms, the AC and the DC. Okay, one straight line indicates the DC and the sinusoidal wave, it indicates the AC. Okay, friends?